Hi, welcome to another episode of a CNA's Opus. My name is Rich. I'm a certified nursing assistant, and excuse me for a second. What I really want to go over is some parts of the P53 pathway, and the P53 pathway is a very complex pathway. One thing that I see a lot in some of the videos that I've been looking at is P21, which is a tumor suppressant protein. They seem to just stop uh, at some point and say, just the role of P21 is to stop cyclin-dependent kinase 4 and cyclin D uh, from phosphorylating and changing conformation of the retinoblastoma protein so that E2F and its binding domain um, don't go from G1 to S phase in the cell cycle. It's a lot more difficult than that. One thing I want to say before I start talking on any more is I'm talking about this to kind of reiterate um, what I'm learning, so that it kind of sticks with me. If you want to try to follow along, I'll do my best, but it's kind of all over the place, unless I have a diagram. But I'll do the best that I can to try to talk through it. Anyway, P21, there's damage in the DNA, and P21 will be produced, is one of the things that can be produced to halt the cell cycle. And one of the ways that I just mentioned is that it will bind to cyclin-dependent kinase 4, and that will keep cyclin D from binding to it. So that cyclin-dependent kinase 4 is inactive, and it can't phosphorylate and change the conformation of retinoblastoma protein. So the transcription factors in there, E2F and its binding domain, can't go do its function. That's very early on in the cell cycle. That's in G phase. In G phase, you're making these preparatory proteins, kind of these free protein complexes that will go on to the origins of replication. And the origins of replications are where DNA polymerase will bind to and start making the complementary bases to replicate the DNA. But it's a precursor. It's not quite there in G1 phase. It just gets it ready in G1 phase for the next step in the cell cycle, which is the S phase, or the synthesis phase. And if you see it on a diagram, sometimes you'll see it as a circle. We usually see it as a circle. Anyway, there's another tumor suppressant protein called P27. And P27 will also bind to CDK4, or cyclin-dependent kinase 4. And that will keep cyclin D from binding. So it becomes active because of the tumor suppressant protein P27. And P27, the difference is that it's specific for cyclin-dependent kinase 4, as where P21 is not specific, just for cyclin-dependent kinase 4. So there's another cyclin-dependent kinase and that's cyclin-dependent kinase 2. And cyclin-dependent kinase 2 binds to cyclin E. Now this cyclin-dependent kinase 2, which binds to cyclin E, can still phosphorylate and change conformation of the retinoblastoma protein, so that its E2F and its binding domain transcription factor can be released. However, it has an alternate function, and its alternate function is to phosphorylate and change conformation of the P27 protein, which is the tumor suppressant protein that is specific to cyclin-dependent kinase 4. So when it phosphorylates it, it changes that conformation. So cyclin-dependent kinase 4 is released. So then it can again bind back to cyclin-dependent cyclin D, and then go and phosphorylate and change conformation of the retinoblastoma protein. Start the synthesis phase. Once the synthesis phase, once E2F gets E2F and its binding domain go to its promoter region, the E2F box right there, it'll increase the affinity and pull in RNA polymerase complex 2. And that will start, one of the things that will start transcribing is for a protein called cyclin A. And the cyclin A is vital here to continue the cycle in S phase. So before we had G phase, now we're in S phase. And what it does is the cyclin-dependent kinase 2 that was binded. I know this is all over the place, but the cyclin-dependent kinase 2 that was binded with cyclin E originally. Now that cyclin-dependent kinase 2 will bind with cyclin A. When it binds with cyclin A, it has a different function now, has a different role. Its new role is, if you remember back earlier in the video, I said in G1 phase you made those pre-protein complexes at the origins of replication. And what cyclin A and cyclin-dependent kinase 2 do is its new job, instead of phosphorylating P27 or phosphorylating the retinoblastoma protein, what it does is it acts like an enzyme, and it goes in and it changes the conformation of the pre-protein complexes at the origins of replication. So now it's ready at the origins of replication. It's ready for DNA polymerase to come in and start replication. But if P21 binds and inactivates CDK2, it'll arrest the cell cycle in S phase. So before we had it arresting in G phase, now we have it arresting in S phase. It could also be arrested in M phase because there's 3 cyclin-dependent kinases, and this is that's cyclin-dependent kinase 1, which plays a major role in the mitosis, which is the end. So if P21 binds there, then you could arrest the cell cycle at that point. So there's multiple stages that the cell cycle can be arrested. there. In the next video, I really like to talk about the intrinsic apoptosis pathway in the mitochondria and cytochrome C, and more on the p53 pathway, more at the DNA level, because I'm kind of like in the middle of the pathway right there. But anyway, again, it's kind of to reiterate what I know, so I can retain it. But if you gained anything out of it, I'll see you next time. All right.